Hi, Mrs. Stanley here. Let's do a discovery activity on distance and midpoint. For this activity, please take out a pencil, paper, and a straight edge. Just to be clear, a straight edge could be anything that you could use to help you draw a straight line. It could be a ruler, a piece of paper, a card, anything that makes a straight line. It might help to have grid paper, but any paper is fine. You'll notice when I show you some examples that I just used regular paper with lines, but having the grid will help you to plot points easier because we will be plotting some points. You may also want your colored pencils, but it is not necessary. Again, in my examples, you'll see that I use different colors to mark different information that we're going to get throughout the activity, and that way it's sort of color-coded and I could keep everything straight. That's optional. So go ahead and gather whatever supplies you need, pause the video while you're getting those supplies, and then come back and join me to continue. Let's activate some prior knowledge. How do you find the distance between 2 points on a number line? Just think through, brainstorm some ideas. If you have this drawing here with A and B, how could you count the distance or calculate the distance between A and B? How far is it? Okay, some of the options you may have considered is that I could just count how many spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one way to do it when I have an actual number line, right? Another way that you might have thought to do it is to say, okay, from 0 to 6 is 6 spaces. And from 0 to -4, even though that's -4, it's still 4 spaces. So 4 plus 6 is 10. We got the same answer. Another way that you might have thought of is to just take the numbers and subtract them. Just like if I say, oh, I was born in 1979, how old am I? You would say, well, now is 2021, subtract 1979. In this case, if I want to know the distance between A and B, I can say, well, B is at 6 and subtract A. A is -4. Well, what happens when we subtract a negative? We end up adding, and notice that we still get 10. So these are all different ways to do it, but what I want you to notice that the one that is most close to what we do in algebra and higher level math would be this last option, because it's just doing a pure calculation, and what we did is B minus A. Okay, so we just want to keep that in mind because it could come in handy later. Coming to the next question, how would you calculate the midpoint? So I have the same drawing, I have the same 2 points, A and B. How could I count or calculate the midpoint? Just like we said earlier, you could count 10. We have 10 spaces and we know that halfway to 10 is 5. So there's 1, 2, 3, 4, 5. So this has to be the midpoint, +1, right? That's one option of how you could do it. We could say, well, we already know the distance is 10. So let's do 10 divided by 2, and we'll get 5. And so we know what is 5 away from either point. I could do 6 minus 5 and get 1, or I could do -4 plus 5 and get 1. Either way, my point is going to be at 1. Why does it work out that I can add 5 to the smaller number and subtract 5 from the bigger number? Well, think about it. I'm looking for what is in the middle. If this is the middle of the line, then the distance on each side has to be the same, right? So those are some options of how I could calculate the middle. All right, let's keep going. Here's a question. We've got this triangle here. How do you find the length of AB in this right triangle? Notice that AB is this side right here. How do I find this length? I'll give you a hint, the Pythagorean Theorem. So if you remember, Pythagorean Theorem is a squared plus b squared equals c squared, which means you have to know which one is c. And if you recall, this is our right angle, and the right angle always points at c. So we could say that 24 squared plus 5 squared equals c squared. So if we think that through, that means that c equals the square root of 24 squared plus 5 squared, right? So we can work that out. So we've got 24 squared is 576 plus 5 squared is 25, which when we add them together we get 601. And then the question is, can we take the square root of 601? we can't take an exact value, but if we use a calculator, we can estimate that it's going to be about 24.5. And so actually, instead of using an equal sign, you could use equals, but you can also use a symbol like this. It means approximately. So this is about 24.5 centimeters. Notice that these units are centimeters. So that's how we would find the length of AB, correct? We would use Pythagorean theorem. So keeping all of this in mind, we're going to move to the next step. So on your graph paper or regular paper, whatever you have, draw an X and Y axis, but notice this second line before you start drawing. We will only be using quadrant 1, so 0, and that's supposed to be a comma. The point 0, 0 does not need to be in the center of the page. I will go ahead and show you an example. This is how I drew mine. This is my X and Y, and like I said, this is just regular lined paper. My scale is not excellent. The Y and the X don't match very well, but it's fine. So here's what we need next. Tracy lives at 1, 2. So this is a point, right? It's an X and a Y. Let me use a different color so that it shows up a little better. This is X and Y. Go ahead and plot that point on your paper. And also, she wants to visit Amy for her birthday. Amy lives at 710. So X is 7, Y is 10. And I plotted these in different colors. I'll show you my example again. Here is Tracy down here at the bottom at 1, 2, and Amy's house up here at 710. These are where they live. Go ahead and pause as you need to. I'm going to keep going so that the video is not longer, but you can pause in order to do things. She decides to walk to the corner store and then pass the bookstore at 7:06 on the way in order to purchase a present. So pay attention to that. She decides to walk to the corner store at 7:02. So you need to plot that. Again, I used a different color for each of these points and I labeled them. Corner store is at 7:02 and the bookstore is at 7:06. Go ahead and graph that. Here is my example. I've got Tracy over here at 1, 2. I've got the corner store at 7:2. We go up to the bookstore at 7:06. And I've got Amy's house at 7:10. And notice I used the color. When Tracy went to the corner store, I used blue because that's a blue point, and then orange when she was going. Notice it doesn't say that she like stopped and hung out at the bookstore or changed or whatever, but she went there on the way to Amy's house. So there wasn't any circling back. Okay, how far did she walk to get to Amy's house? So using your diagram, how far did she walk to get to Amy's house? Think that through and look at your diagram and calculate your answer. So what we can see is that on the x-axis, she went from her house, Tracy's house, to the corner store. So she went from her house to the corner store on the x-axis, and we know she started at 1 and she went to 7. Remember earlier when we talked about finding the distance on a line, we could do the end point. She went to 7. Where did she start? 1. So she walked 6 units sideways, 6 units this way. And then to go from the corner store to Amy's, she went from the point 7.2 to the point 7.10. And we know that if we want to go up and down, we look at the y's. So where did she end up? She ended up at 10 and she started at 2. So how far did she go? 8. The total distance is how far she walked sideways and then how far she walked up and down. So maybe she went east and then she went north. So she walked 14 units. We weren't given any centimeters or meters or kilometers or miles, so we're just going to say units. So she walked 14 units to get to Amy's house. How did you calculate the distance that she walked? This is the question that you would want to answer. Coming home, she will take the shortcut through the park and past the pond. How will you calculate the distance she walked to go home? So on your diagram, go ahead and draw if she's taking a shortcut through the pond, walking straight from Amy's house to her house. How will you calculate the distance she walked to go home? And you might be asking yourself, wait, there isn't a park or a pond. Just keep in mind what I'm telling you. She's walking straight home from her house, from Amy's house to hers. Let's look at my diagram. Now that you see my diagram, is this how you drew it? The blue line is the shortcut home. How could you calculate this distance of the blue line? This one right here. How do we get this distance? Think back to our example early on when we first started and we said we were activating knowledge. This is a right angle, a right triangle. Right here is the right angle. Okay, so, and we know that because these points are all on the x value of 7, right? And these 2 points are on the x value of 2. So we know that it was, the y value. So we know they went straight across and then straight up. That has to make 90-degree angle. So we can use the Pythagorean theorem. We already said in our previous information that right here, it was 7 minus 1, which was 6. And on the tall side, it was 10 minus 2, which is 8. So using the information that we have, we know that we can do the square root of 6 squared plus 8 squared. Well, the good news is those are pretty easy numbers. 6 squared is 36, 8 squared is 64. Add them together, you get 100. What is the square root of 100? It's 10. So now we know that the shortcut home is only 10 units. So instead of going over 6 and up 8 for a total of 14, she just went 10 units. Okay, let's keep going. As Tracy is walking home through the field, she stops to dangle her feet in the pond that is exactly halfway between Amy and Tracy's house. Give the coordinates of the pond. So, think about where would the pond be and what would be the coordinates. So I'm going to use a different color. I'll use the green. We're saying that she started here and she went here, and halfway in between there's a pond. And she's dipping her feet in there. How can we figure out what exactly is the middle? Okay, let's look at my diagram. Here's my pond. How would we calculate that out? Well, here's what I know. Halfway between here and here, we already said that we could add the two numbers. I have a 1 for the x and a 7. What's 1 plus 7? It's 8. So to get in between them, I need to divide by 2, which is 4. So I'm going to go over 1, 2, 3, 4. So here's my x point. Let me try a different color for the y. For the y, we know that halfway down between the top and the bottom is halfway. The blue is not a good choice. Let me use red again. So halfway from here to here, we know if we add them together, 10 plus 2, and divide by 2, we get 12 divided by 2, which is 6. Whoops. So I'm going to go up 6, but I'm going to go from my x. But starting at the x-axis, I just mean that I'm going straight up and down. This was over 1, 2, 3, 4, which is what we got right here. And now I'm going to go up 6. 1, 2, 3, 4, 5, 6. And look, that's right where my pond is. So what is the coordinate? It's 4, 6. So the way that you could have just figured it out is just counting the up and down and the sideways and finding out where would be the middle. The other way is to do the math, which I did over here, which was add the 2 points and divide by 2, right? Okay, let's keep going. The last thing that's in this directions is that you have another page called the Discover number 2. And so what I want you to do is use this information to answer the questions. There will be a similar situation where you're going to graph it and try to figure out some information like we did here. Keep in mind what we talked about at the beginning. We talked about that you can find the length of the side of a triangle using Pythagorean Theorem and what that looks like. And then we'll come back together in the next class. We'll actually give you this information. In the next lesson, we'll go over this and figure out, is there a formula that we could use that would always work? Okay, so thinking about what we know, we already looked at finding the distance of this side, and we looked at finding the distance of the height on this side, or the length of this side of the walk. But let's focus on just the bottom one for right now. We know that she started at 1 and she went to 7, and we calculated 7 minus 1 was 6 spaces. So if we went from 1 and we went over 3, that would put us right here at 4, right? That would put us in the middle between the 1 and the 7. Well, here's the thing to think about. If I wasn't looking at the diagram, I only knew that I had 2 endpoints, 1, 2, and 7, 2. How could I find the middle? Well, think about that. We said that this is right here at 4. So I just want to put out for you a mathematical idea. This point is 1, and this point is 7. What if we add them together and divide by 2? 8 divided by 2 is 4. Interestingly enough, we got the center number. Think about that. It's kind of like taking an average. If you told me that you made a 100 on an assignment and you made a 90 on another assignment, what's your average? Well, it would be right in the middle. 100 plus 90 is 190 divided by 2 is 95. So I wouldn't have to do all that math. I could just say, oh, well, the average is in the middle between 90 and 100 would be 95. So same thing, if I'm going to find this distance here, I want to find the middle. We said that we know this point is at 10 and this point is at 2. So we did 10 minus 2 to get 8. That means we would divide by 2. It would be 4 spaces from here. 1, 2, 3, 4. So my pond is actually up 4 from here. 1, 2, 3, 4. Right where I drew it. But again, thinking about what we said about finding an average. When we want to find an average, we can take the 2 that we know, add them together, and divide by 2. We would get the middle, right? It's like taking an average, the same thing as finding the middle. 10 plus 2 is 12, divided by 2 is 6. So we still get that same point. When we use our math here, we get the point for 6, and we can tell by looking at the diagram that that is right in the middle.